An oblique or slanted asymptote for a function f of x is such a line, let's say with the equation mx plus b, that the point x f of x comes closer and closer to that line when x increases without bound or x decreases without bound. The picture illustrates the relationship between the graph of the function in blue and oblique asymptote in red. Let's say that asymptote has the equation mx plus b. If you look at the points x sub 1 f of x sub 1 and x sub 2 f of x sub 2 and x sub 3 f of x sub 3, you can see that the values of x are increasing, and we can say they could go further and therefore increase without bound, getting larger and larger. Corresponding points on the graph are going to approach the line y equal mx plus b. The further we are to the right with the value of x, the closer to the line y equal mx plus b we will be. Similarly, on the other end, if x is decreased without bound, so x's are negative, the points on the graph are going to also come closer and closer to the line y equal mx plus b. So this is the relationship that shows that the line is mx plus b is an oblique asymptote for the graph of the function f of x. As with the horizontal asymptote, existence of the oblique asymptote determines the end behavior of the function. We are looking what's happening when x increases without bound, so on the extreme right, or decreases without bound on extreme left. So if a rational function has such asymptote, then we know exactly how the function is going to behave when we move far enough to the left or far enough to the right. It is worth mentioning that a rational function can cross an oblique asymptote, and if such oblique asymptote exists, it's only one. On the left and on the right, the asymptote will be the same. And of course, we can draw many other graphs that have this behavior. So, for example, if the red line here is my oblique asymptote, the graph of the function could be, for example, like this. We said that the graph can cross the oblique asymptote, so let's say we can draw the graph that has this behavior and it's continuous, it crosses the asymptote, or we can draw anything else that we would want to draw with that function, as long as at the extreme left and extreme right the function comes closer and closer to that line.